Hello, Trig class. I am going to discuss Trig Form for complex numbers. Eventually, we're going to finish up our review of complex numbers. You only had one operation left, so let's look at that. We have, let me set my timer, hold on. I haven't done any kind of comp book check, so show me your notes on Monday, and we'll also catch up our contents, table of contents. So in the future, if you ever need these things, you can find them quickly. All right, sorry. Let's see, 12 minutes, pretty good. So we'll go from there. All right. When we have a complex number, remember it had a real part and a complex part. The complex had the I, and when we have that situation, we can divide two complex numbers, such as 3 plus 2i, and say minus 4 plus 5i. I wish I could remember the ones I was doing in class, but I made them up, so I don't remember them now. So let's look at division of two complex numbers. If you want to use the complex numbers that we started our examples with, you can watch this and use the principles to substitute the numbers in your that we were using in your comp book. 3 plus 2i divided by minus 4 plus 5i. We're going to divide those by multiplying by a form of 1. Remember, anything is equal to 1 if it's something divided by itself. So when you multiply by a 1, it doesn't change anything, but it changes the form but not the actual value. But we're going to multiply by the conjugate, and we've been doing that off and on this year when we come up with radicals in the bottom when there's two terms. So this is two terms, this is a radical. Remember, it is the square root of -1. So we're going to treat it similarly. The conjugate is going to have the same first term, and the second term takes on the opposite sign. So putting that over itself, I have 4 steps in the top. I multiply in this fashion. You multiply the way you're used to, in the order you are used to, and we'll get the same thing. Let's see, negative 12, negative 15i, negative 8i, and a negative 10i squared. Now the thing about the negative 10i squared is we recall on our little key from class on Friday, whenever we have, let me see if I can get the whole thing in here. Whenever we have this situation, I'm just checking. All right. Whenever we have an I squared, we're going to replace it with a -1. So keeping in mind that that's equal to -1, all that does is change the sign. Negative 10 times a -1 is a positive 1. So I'll just do it like that in a quick but sloppy way. Now on the bottom, you don't have to do as many steps because when we FOIL, the inner and outer products will always cancel each other, because that's why we multiplied by this. So all I have to do is first times first and last times last. Works every time. If you're not convinced, do the 4 steps. All right, so negative 4 times negative 4, and positive 5i times negative 5i. And once again, we have that little maneuver where we replace I squared with a -1, but all that does is change the sign in front. So I end up with a 16 plus a 25, which is 41. And we will always have no i's in the bottom because that's why we multiply by the conjugate. And on the top, I've got a negative 12 and a positive 10. And I've got a negative 15 and a negative 8i. Alright, and then I check to see if that can be reduced. So when I add this, I get a 41. It doesn't have any factors in common with the two terms in ahead of it. Alright, so that's how you divide. Alright, that was just a way of review to see how to divide complex numbers, multiply by the conjugate. Alright, on to what we are aiming for here, and that is to represent complex, remember, complex numbers in trig form. So this is called the standard form we've worked in so far. So let me show you. I'll just pick a number and I'll transform it from standard form to trig form, and I'll tell you why in a little bit why we would do that. So to go to trig form, it's going to look like this in the end, so keep your eye on the prize. There's going to be a number out here called, well, it's usually represented with an R, excuse me, an R. I think I know why. I'll tell you a little bit why. It's called the modulus, which will help me refer to it later. Cosine theta plus I sine theta. And these two thetas are the same. So if this is the angle pi over 3, so is this. So let's repeat in r cosine plus I sine, r cosine plus I sine, r cosine theta plus I sine theta, r cosine of an angle plus I sine of the angle. Say that to yourself a lot. You want to recognize and establish that pattern often in the section, so kind of study it with your ear or your eye, however you learn best. Alright. I had a tactile learner on one of my children, so if I wanted them to learn it, we had to like draw it in the sand, so they had to feel it. So do what you have to do. Alright, here we have a graph of this, and I am going to graph, I'm sorry, I want to make this plus. I don't know why I did minus. Would you go up and just change that to plus? So I'm going to go over 3 on the real axis. Remember the real part is on the formerly x-axis, and the imaginary part is on the former y-axis. So I'm going to go over 3 and up 2. So I found this point on the complex plane. And I want you to draw a component, a vertical side, a horizontal side, and then connect the origin to the point. So we have a right triangle, which we are wont to do. So if this side was 3 and this side was 2, Pythagoras can come along and tell us that that side is the square root of 13. So confirm that. And then if I need to know that angle, we can do that as well. The tangent will help us with that. So if I go the tangent of this angle is going to be opposite over hypotenuse, 2 over 3 equals, let me check that. Make sure you're in degrees. I got 30, about, I'll round it, 34 degrees. So this is 34 in here. So we have all the parts that I need for trig form now, and here's what it will look like. Well, let me show you why this comes out, and then we'll go learn to do this quickly. All right, so especially if you were in physics class, we can easily take this component and rewrite it as square root of 13 sine of 34, because I'll show you why on the first part. Here's what's going on in your thoughts. We can see that the sine of 34 is opposite side, what is that? I crossed it out. It is a 2. It's going to be side opposite divided by hypotenuse. opposite is 2, hypotenuse square root of 3. So the sine of 34 degrees, I can multiply both sides by the square root of 13. And I see that the 2 can also be written as, that's why I crossed it out, I can rewrite it as square root of 13 sine of 34. We do this in physics at the drop of a hat. And we can rewrite this as square root of 13 cosine 34 for a similar reason. So now, instead of saying that this number here is 3 plus 2i, I have some other values with trig functions in them. I can say it's square root of 13 cosine 34 plus, and then this side, which is square root of 13 sine of 34. But remember, we're on the I, the imaginary axis, so I have to plug in the I like I did here. So here I can remove what's common to both of these terms, and I get square root of 13. If I remove a square root of 13, these are a term, this is a term, and this is a term. Terms are held together by multiplication or division and separated by plus or minus signs. So I got to remove the square root of 13. What's left in the first term is cosine. I just cover it up if you can't see it. And over here, when I remove the square root of 13, what's left? The sine of 34i. And I'll put the I out in front of this term. Oh, no, I won't. Because in this form, we kept it in the back, so. Alright, so cosine, I think I will, because see here in this form, I put it out in the front. So we're flexible. Front, back, as long as it's in the same term. So I sine 34, now I'm happy. Alright, so that is called the trig form of the number that we started with here, 3 plus 2i. So these are identical, just two different forms. So once I do not have to go through this every time. So here's the what I expect. Say I say 3 plus 2i, and I want it in trig form. You will have to sketch it and put in a 3 and put in a 2 and find that this angle with the inverse 10, you must find this is 34, and with Pythagorean, find that this is square root of 13. But then you can go quickly to the r cosine theta plus I sine theta form, and it's square, this is the modulus, square root of 13, cosine the angle plus I sine the angle. And we just showed why that is true. Alright, that's part one. Let me shut this down and get on to part two.